Hey, Trig kids, I'm recording from home today. I was supposed to be back, but daycare is closed today, so I'm home with my kiddos. So I'm going to run you through section 1-6 geometric sequences. It's pretty straightforward. Since we've already done like arithmetic sequence, it's going to be fairly easy until you get to the second page, like these type of problems. So basically the second page is going to be just a touch harder, but you should be able to get through the first page. So I'll go through most of it, maybe all of it, depending how long it takes, and then maybe on Tuesday we'll go over questions and whatever else we need to do for damage control. So just be prepared for that. We're going to go through 1-6. We'll turn homework in for 1-5 on Tuesday and go through questions. So geometric sequences I'm going to add to the top of this page. Like arithmetic. Let's talk about arithmetic for just a second. Arithmetic. Arithmetic was plus or minus. You're adding or subtracting something each time, and those are linear functions. So those, if you graph them, look like a straight line because you're going up or you're going down by a certain number each time. That's supposed to be a plus sign. It kind of looks like a little F, but whatever. Geometric. Geometric sequences we've talked about kind of a little bit before, and those are either multiplying or dividing. And those look like exponential functions, okay? Exponential functions look kind of like that. So they start out real low and then they go really, really high. Or sometimes they'll start out real high and then they'll level off like this. So both of those are exponential functions. Now, in a geometric sequence, you will never deal with actual division symbols because when you're multiplying, like let's say you're doubling something, that would be like multiplying by 2, okay? If you are dividing by 2, that's the same thing as multiplying by 1/2. So they will use entirely multiplication for geometric sequences. Just know that when it's a fraction, that's actually division. Okay, so dividing by 1/2 is the same thing as, or dividing by 2 is the same thing as 1/2. Okay, so in a geometric sequence, you have the same thing. You have a common ratio, and a common ratio, or a common ratio for like in arithmetic sequences was called the difference ratio, or that was where you were adding that number or subtracting that number each time. So common ratio is just what you're multiplying each time. So are the following geometric sequences? If so, what's the common ratio? So from here to here, here to here, here to here, here to here, we're looking for something that we're multiplying each time. And this one is a yes. You are multiplying 3. Okay, this one we're looking for something that you're multiplying each time. So what I'm seeing is that the bottom is changing, and the bottom is basically being multiplied by 2 each time. So yes, this is a geometric sequence, but the entire thing is being multiplied by 1/2. So the common ratio is 1/2 here. The common ratio is 3 here. So both of those ended up being geometric sequences. Okay, so now we go to recursive, and then down below we'll have explicit. So those are the two types of functions that we have. If you remember back from recursive, it might be a good idea to have your note card out at this time. So get that guy out if you haven't already, because these are all written on your note card. Okay, so recursive is they will call it U sub n. U sub n. U sub n equals, and then they'll say some number times U sub n minus 1. That's basically what this formula is saying, and they call it R, your number. Okay, so this is the number that you are multiplying, and this is the one before it. So number before U sub n. So if I'm trying to find the 9th term, I would take whatever I'm multiplying by the 8th term. If I'm trying to find the 52nd term, I take the number times the 51st term, okay? And the problem again with recursive is that if I want to know the 52nd term, I have to know the 51st term. And if I want to know the 51st term, I have to know the 50th and the 49th and the 48th. So that's bad. That's kind of a problem with the recursive formula. It's easier to compute and easier to do, but I can't just automatically find the 52nd term or whatever. I have to, in order to do that, I have to have an explicit formula, which we'll get to, okay? Which is a little bit harder to come up with, but again, it's better for the fact that I can plug 52 in and get my answer, okay? So in example 2, find the common ratio of a geometric sequence where U1 is 2 and U2 is 8. Okay, if this set arithmetic sequence from 2 to 8, I would be adding 6, right? If this set arithmetic, you would be plus 6, right? If arithmetic, you would be adding 6 each time. But since this is geometric, we know that we're multiplying, okay? So from 2 to 8, we are multiplying by 4. So I'm going to put my common ratio, or R, I'm going to put CR because we had R in the last section. That was a completely different R. Common ratio is 4. You're multiplying by 4. Okay, so list the first 5 terms of the sequence. So U1 was 2. I'm going to do my curly brackets. U1 was 2. U2 is 8. If we multiply by 4 again, that's 32. Multiply by 4 again, that's 128. Multiply by 4 again. I don't know. I'll have to get paper out. Hold on. 128 times 4. 2, 1, 3, 1, 1, 512. Something like that. 512. If that's not right, you fix it. I don't know. But 2832, 128, 512. Okay. So this is 1, this is 2, this is 3, this is 4, this is 5. 5 terms. Okay. So if I graph it, the 1 is at 2, the 2 is at 8, which is up here somewhere. The 3 is at 32, which is like maybe almost off the graph. Then the next one is like all the way up here, and the other one's off the page. So it's kind of going up gradually to start with, and then all of a sudden it's like zoom all the way up. Okay, so that's an exponential function. All right, 4 is a pretty big term to be multiplying each time. If this number was like 2 instead, it would level off a little bit more before it goes up really fast. Okay, so but because 4 is like kind of a bigger number to start with that you're multiplying each time, it's going to go up right away. Okay, so example 3, confirm that the sequence defined by u sub n equals 2 u sub n minus 1, where u sub 1 is 7, can also be expressed as this guy. Okay, so we're just going to kind of talk about the differences between this function and this function, because one of them is recursive and one of them is explicit. This guy is recursive, and this guy is explicit. Okay, so in this case, my recursive formula is just saying I'm taking 2 times, go back up to my pencil here. I'm just taking 2 times my one before it. That's all that's embedded here. Okay, now the explicit formula, I like the way that they've written this because 2 is going to be my base. That's the part that's going in the exponential function. I'm multiplying that by each time. And then my exponent is x minus 1 or n minus 1. We're going to talk about that here in just a second. The 7 is my first term. Okay, this is the number 7, my first term. All right, now normally in the arithmetic sequence, I told you that your first term, this guy right here, had to be u sub 0. Okay, right? U sub 0 has to be all the time. Your first number that you're starting with has to be u sub 0, except the way that they've embedded this in the formula, they have done it to the x minus 1 power rather than doing it just to the x power, right? If you leave it as just to the x power, this has to be u sub 0. But because they did x minus 1 power, they are going around that, and I can plug u sub 1 into this spot. So that makes it really, really super nice for us. So if you want to do the use or the x minus 1 power, that's fine. You get to kind of cheat on this guy a little bit because you don't have to find u sub 0. Okay, so the explicit form. I'm going to put I'm just gonna write this out a little bit bigger. U sub n equals u sub 1 times r to the n minus 1 power. Again, this is my first term. Okay, now I'm going to say or u sub n equals u sub 0, if you have u sub 0, times r to just the n power. You don't have to subtract 1 when you're already at u sub 0. So this formula is embedded so that if you have u sub 1, that's really nice and you don't have to go around and find u sub 0. this is the same thing as that. So either one of those equations you can work with. This one's going to be easier for these next couple problems. So write the explicit form of a geometric sequence where the first two terms are 2 and negative 2/5. Okay, so I'm going to write this out. U1 is 2 and U2 is negative 2/5. Okay, so we have to figure out what we're multiplying each time. Okay, now looking from this guy to this guy, I am multiplying a negative 1/5. Okay, I can do that in my head, but if you cannot, here's how you do it. You take the second one, the negative 2/5, and you divide by the first one, which is 2. Okay, I'm going to put 2 into a fraction, put it like 2 over 1, and when you're dividing by a fraction, you are going to multiply by the reciprocal. So I'm going to multiply by 1/2, where the 2's can cross out, and all I have left with is negative 1/5. Okay, so if you can do it in your head, that's fine. If you can't, take the second term, U2, and you divide by U1. Okay, that's how you do that. So negative 1/5 is my common ratio. So this guy is going to be really easy to write the explicit form. It is just U sub n equals, my U1 was 2. I'm going to multiply that by negative 1/5. And since I'm using U sub 1, I have to do n minus 1 power. Okay, now I'm gonna have you guys circle that as an answer, but then I'm going to show you what it would look like if you're doing U sub 0. So U sub n equals, I'm going to find out what U sub 0 is, but I'm going to multiply by negative 1/5 to just the nth power. Okay, so I'm going to use this formula here, and I'm going to show you what this looks like, so you don't have to worry about the n minus 1 in the exponent. So what we're looking for is we're looking for U sub 0. So I'm going to go back here, and I'm going to put U sub 0. Okay, so what we're doing is we are multiplying by negative 1/5 each time. So this number that I'm looking for here is a number that when I take 1/5 of it will give me 2. Okay, or you can take 2 and divide by negative 1/5. That guy is going to be negative 10. Negative 10 times negative 1/5 will give me 2. Okay, so I'm going to put negative 10 in this spot. And there is what this guy looks like with just U sub 0 embedded in, okay, rather than U sub 1. You are more than welcome to use this. In fact, I would encourage you to use that one because that one is easier, okay? But if at some point in time they give you U sub 0 instead of U sub 1, like they do with some data sets, you're going to be using n instead, okay? So if that confused you, just ignore this little part of it. Go with this answer, all right? Let's go to the next page, and then we'll be almost done. All right. The fourth and the ninth term of a geometric sequence are 20 and negative 640, all right? Pay very close attention to this because this is where it gets kind of confusing. U sub 4 equals 20, and U sub 9 equals negative 640. So what our goal is now is to find what R is. Okay, we need to figure out what our ratio is that we're multiplying by each time. Okay, if this was an arithmetic sequence, you would take the y2 minus y1 over x2 minus x1, etc., right? But this one, you're multiplying by something each time. So basically what you're doing is you're starting with the number 20, and you're multiplying it by some number to get negative 640, okay? You're multiplying it by some number to get negative 640, and that number we're going to call R, okay? But since we're starting with the number 4 and going to the number 9, we are doing this 5 times because 9 minus 4 is 5, okay? So we're starting with the number 20, and we're multiplying 20 by this number, 20 by that number again, 20 by that number again, and by that number again, by that number again, 5 times to get negative 640. So that's the equivalent of saying this expression. So what we have to do now is we just have to unwind this equation to figure out what R is, okay? So to unwind this equation, I'm going to start by dividing by 20. Divide by 20. He's going to go to the other side. Divide by 20. Oh boy. R to the 5th power equals negative 32. So then, how do you get rid of the 5th power? You are going to take the 5th root, like it's like the 5th square root, but it's not square root anymore, it's the 5th root. So that just becomes out r equals, and what we're looking for here is a number that you can multiply by itself 5 times to get negative 32. And that is negative 2. Negative 2 times negative 2 times negative 2 times negative 2 5 times is negative 32. So that is what my r is. Awesome. Negative 2. Negative 2. Okay, and then what I have to do is I need to write the explicit form. So I'm going to say u sub n equals, we have to figure out what u sub 1 is, times negative 2, that's where my r is, to the n minus 1 power. Okay, so we need to figure out what u sub 1 is. I knew u sub 4, but I don't know. Let's see, it might be easiest to just backtrack here. And then I'll show you how you can shortcut this. Okay, so to go from 20 to the next term, I would multiply by negative 2. So u sub 5 would be like negative 40, etc., right? So what I'm going to do is, instead of multiplying by negative 2, I'm going to divide by negative 2 to get back here, right? 20 divided by negative 2 is negative 10. Okay, and then I'm going to backtrack again. Negative 10 divided by negative 2 is positive 5. Then 5 divided by negative 2 is negative 5 over 2. Okay, so negative 5 over 2 is going to go in that spot. That's going to be my u sub 1. Okay, again, we could have gone back again, which would be like positive 5 over 4, and done just n. And if that confused you, just don't listen to what I just said. But we'll do it this way, okay? A way of getting around that, if you didn't want to backtrack each time, to get from 4 back to 1, I would have to do that process 3 times. So I could take 20, again, if this is confusing you, just stop listening. I could take 20 times negative 1/2 to the 3rd power, because I'm starting with 20 and I'm backtracking 3 times, but I'm multiplying by negative 1/2 this time, or basically taking, you could do it this way, 20 divided by negative 2 cubed. You can do it that way. That's basically kind of what we did to go from 4 to 1. So you wouldn't have to write each of these pieces out. You could have done it that way to get back to the negative 5/2. So this is the explicit formula. That was gonna be pretty hard, I think. So there's how that works out. I'm gonna skip down to example 6 and show you how you make this Riemann sum that we can just type into our calculator. So we have negative 3/2, and then we're going back to negative 3 over 5/12. Okay, so let's go ahead and write the explicit form for this sequence, and we're going to kind of show like what we're going to. Explicit form, that's not an E. Explicit form. Okay, explicit form of the sequence. Our first term is negative 3 over 2. So first term times my ratio to whatever power, to the n minus 1 power. Okay, so my first term is negative 3 over 2, and then we just have to figure out what we are multiplying by each time. So from this guy to this guy, and this guy to this guy, my bottom number is changing, but then my sign is flipping. So when my bottom number is changing, that's like me multiplying by 1/2, right? We saw that at the very, very first start, and then I'm going to put my negative in there, okay, because that's going to show me the sign is flipping each time, okay? So this is my explicit formula, right here, okay? And then what I'm going to do is I'm going to do the sum. I'm starting with n, and I'm going to a certain number, and I'm just going to write that equation in there. Negative 3 over 2 times negative 1/2 to the n minus 1 power. Okay, this is my whole formula, and I just need to plug my numbers in here. Okay, so I'm starting with the first term. This is term 1, right here, and this is 2, 3, 4, 5, 6, 7, 8, 9. Term number 9 is going to go up here at the top. So I'm starting with 1, going to 9. This is my sequence. Just hit a button. Okay, so I'm going to pull up my graphing calculator here and see if I can get that thing typed in. There we go. All right, on. Okay, so if you don't remember where you go for your sequence, you go to the math button, and I'm going to go down. If you don't have a calculator out right now, just pause this video and get your calculator out. So math, again, math button, go all the way down to summation and hit enter, okay? And my, in this case, I tried this again, and you know how we went to mode and we changed our thing from function to sequence? You don't necessarily have to be in sequence, so I'm just going to go ahead and leave it in function mode, and we're going to say x is going from 1 to 9. Going over, I have negative 3 over 2. I use that division symbol to do negative 3 halves, times, I'm going to do negative 1 half to the power of x minus 1. Okay, so I'll go through all that again real quick. So I have my parentheses opened up. I'm going to open up another set of parentheses just so I can write in negative 3 halves. Negative 3 over 2 times negative 1 over 2 to the x minus 1 power. And I hit enter, and it's going to spit out a number for me, negative 1.002, basically. Negative, negative, negative. Come on, it's not going to do it. If that was too fast going through that part of the video, just rewind. Negative 1.002. There we go. And that's the sum of all of those added together without me having to type that in. Super awesome. Now, I probably could have typed that in the amount of time that it took me to fill all this in, but let's say we put twice as many numbers in there. That's going to be really ugly. Okay, so long sequences like that, you're going to want to make an equation and do it that way. All right, and then example 7 kind of shows us what we are using this for. So we've seen this example before. A ball is dropped from a height of 9 feet. It hits the ground and bounces to a height of 6 feet, and it continues to bounce up and down on each bounce. It rises 2/3 of the height of the previous bounce. How far has the ball traveled both up and down when it hits the ground for the 7th time? So my explicit formula, u sub n equals, I'm starting with a height of 9, and it is bouncing 2/3 each time. And I'm going to do n minus 1. That is my entire sequence. Easy, easy. Then, if I want to do the 7th bounce, I plug 7 in there. Okay, so I'm going to do that over here. Clear. 9 times, parentheses, 2 divided by 3, close parentheses, to the, I can do 7 minus 1 power, or you could just put 6 in there. Enter. It will be at a height of, I just covered it up. It will be at a height of 0.79 feet. That's how high it will be after the 7th bounce. Okay, and again, that's not taking into consideration probably like air resistance or whatever else. That's just like gravity in the scenario of this problem, okay? According to this problem, this ball would continue bouncing forever and ever and ever, getting lower and lower and lower, but this doesn't take that quite into consideration yet. That's kind of a calculus level problem. So there you go. That's all I have. I know there will be questions, but do as much as you can on the homework. I will post that on Google Classroom. So be checking that what numbers the homework is, and good luck. Have a good 3-day weekend, by the way.